Wave Swell technology is known as an oscillating water column, essentially an artificial blowhole like you see in coastlines, except that we have a big concrete chamber. It has an opening under the water at the front, and it has a small opening up above. Our system uses what's known as a unidirectional form of oscillating water column. As the waves pass by, the crest of the wave causes the water level inside the chamber to rise, and that compresses the air above. But we have these simple flat valves that open and vent to the atmosphere. As the trough of the wave comes by, the water level inside that artificial blowhole drops and forms a partial vacuum, and that causes the air to be sucked back in via a turbine. Now this turbine is very simple. It only sees the air flow coming from one direction. It generates electricity as it gets spun by this intense airflow flowing back into the chamber as the wave recedes. The turbine that is spinning due to the intense airflow, that's attached to an electrical generator, and the electrical generator creates electricity in the same way that any turbine, hydroelectric turbine, etc., does, or a gas turbine. The ability of the technology to both produce electricity and act as a form of coastal protection puts it in a very unique position in that it is both a climate change mitigation measure, in that it's reducing emissions, but also a climate change adaptation measure, in that it allows for coastal communities to adapt to the inevitable changes of some climate change. The technology was developed to capitalize upon the enormous amount of energy in the ocean. In fact, waves in the ocean, just waves that wash up onto the shorelines of the world, can power the world more than 2 times over. One of the locations that has been identified by the US Department of Energy as a prime candidate for wave energy is a place like Alaska. Just the wave energy incident upon those coastlines is capable of powering 82 million homes. The advantage also of wave energy is that it is very predictable and consistent relative to, say, wind and solar. That enables wave energy to be considered what's called complementary baseload. And what that means is that its timeframes of variation are slow enough that traditional baseload power, like coal-fired power stations, can adapt readily in time to complement energy that's coming or being generated. The technology solves 3 of the past issues with wave energy, and that is its efficiency, survivability, and accessibility. I would expect to see wave energy take its place amongst the world's renewable energy mix in a meaningful way in the not too distant future. And together with wind and solar and other renewables, tidal and geothermal and so on, each of those technologies together will enhance each other and result in a much more resilient and cost-effective energy source. This technology has the ability, in the right locations, to eventually be the lowest cost form of energy and emissions-free electricity at the same time as protecting these communities from the ravages of climate change. Wave Swell Energy was founded in 2016 to capitalise upon the concept of unidirectional oscillating water column, this form of artificial blowhole. Having grown up near a blowhole, a natural blowhole in the coastline, I was struck by the amount of energy. It became obvious that this energy needed to be converted into something constructive that could be used by humankind. The next thing was to generate a technology that could do that, and that's what Wave Swell Energy has now done. And it converts that destructive energy that erodes coastlines into a constructive form of electricity that has no harmful effect on marine life and can also double as a way of preventing coastal erosion. Wave Swell Energy has now developed a product that has solved 3 of the main issues that wave energy has faced in the past: efficiency, its survivability, and its accessibility. With those 3 issues solved, and the ability of the technology to produce low-cost, emissions-free electricity and also double as a form of coastal protection, Swell Energy can perform two climate change roles. One as a climate change mitigation measure, in that it reduces carbon emissions by producing electricity from a sustainable source. Many coastal communities are already suffering from the effects of some level of climate change in regard to higher sea levels and more extreme storm events. This technology can help to alleviate that and act as an adaptation measure for those communities. So what Swell Energy has done to this point is to develop a project on King Island. That project is producing electricity into the Hydro Tasmania grid on the island. In conjunction with that, and to further the technology, is we've implemented what we call Project Bluefire. Now, a bluefire is a jellyfish, the most energy efficient creature in the ocean, making it buildable in a greater range of locations, reducing construction costs. All sorts of additional benefits will enhance the technology, and within the next 5 or 10 years, we would expect to see the technology proliferating throughout the world. Strategic partnerships with larger companies, project developers, energy companies, major infrastructure players who can help to roll out the technology. One of the major accomplishments of Swell Energy has been the development of our first unit at King Island. This has been a really big achievement to go from a concept to something that is producing electricity, and a high quality of electricity at that, into a remote grid. Overall, we expect the King Island project itself to be the first of many different wave energy units throughout the world. Swell Energy is now a leader in this wave energy space, and we have a great product that we would like to see installed throughout the world. The Swell Energy technology has a reliable, low-cost form of electricity. There's no harm to marine life at all. It can produce desalinated water or hydrogen, requires less in terms of battery storage, and also can double as a form of coastal protection, partnering with large energy or infrastructure companies to help get the technology implemented in as many places as possible, as soon as possible, to benefit the world as much as possible.